Chapter 6, Section 6, we are going to be solving exponential and logarithmic equations. So first we're going to be solving exponential equations. So just a reminder, exponential equations are when you have x in the exponent. One helpful tip for us when solving exponential equations, if our bases are the same, so if we have 3 to the power of x is equal to 3 to the power of 5, we can just cancel out our bases that are the same and set our exponents equal to each other. So we would just have x is equal to 5. So we could just cancel the bases out. Still doesn't work. There we go. And just set the exponents equal. All right, so let's look at our first two examples. So we want to get our bases to be the same thing so they can cancel out. So we can either make 100 look like 1 over 10, or we can make 1 over 10 look like 100. What do you want to do? All right, let's make 1 over 10 be 100 to some exponent. So what would that exponent on 100 need to be?
-2.
Awesome, -2. So we're going to change 1 over 10 to be 100 to the power of -2. So we have 100 to the power of x is equal to 100 to the power of -2 and x minus 3. What do we do if we have two exponents there? How do we combine those together? Multiply them. So this would be 100 to the power of -2x plus 6. Once we get our bases the same, we can cancel. Set our exponents equal to each other, so x is equal to -2x plus 6, and then just solve for x. So how would we solve for x here? Awesome. Add 2x to both sides, divide by 3, x is equal to 2. Good work. All right, let's look at B. So for this one, it's a little bit different because we can't get 7 to look like a 2, and we can't get 2 to look like a 7. So what we can do is take the log base 2. So we're using base 2 since we have a 2 there already as our big base. So this would be log base 2 of 2x is equal to what we do on one side, we have to do on the other. So log base 2 of 7. What is log base 2 of 2? It cancels, so then we're just left with x. And x is equal to log base 2 of 7. And then we just want to put that into our calculator. How do we put log base 2 of 7 in our calculator? Awesome. Log of 7 over log of 2. Then we calculator this. .807. Everybody agrees? Awesome. Any questions on this page? We have 3 more examples, solving them just like we did in A and B. So for number 1, this looks just like B. What do we have to do to get the x from out of our exponent? So the log base 2 of 2 cancels, and x is equal to log base 2 of 5. Yep. So x is equal to log of 5. What'd you get when you put it in the calculator? Any questions on this one? All right, number 2. How do we get the x from out of the exponent? Log base 7 of 7 to the power of 9x. What we do on one side, we have to do to the other, so log base 7 of 15. What happens to log base 7 of 7? Cancel. So 9x is equal to log base 7 of 15. How do we put log base 7 of 15 in our calculator? What goes on top? Log of 15 over log of 7. What do we get? 1.391. 2. So then we have to still solve for x. We have one more step that we have to do here. How do we get x all by itself? Divide by 9. 0.155. Let's look at number 3. What do you think we have to do first here? Add 7. Awesome. So add 7. We have 4e to the power of negative 0.3x is equal to 20. What should we do next? Yes, but before we do that, we have to get that e with the exponent all by itself. So we want to move that 4. Divide by 4. So e to the power of negative 0.3x is equal to 5. And then just like we would before, we would take the log base of whatever our base is. So we would take log base e, which, as Connor said, is ln. So we would take the ln of both sides. So what happens to the left side? Ln of e to the power of negative 0.3x. Ln of e cancels. So then we're left with negative 0.3x is equal to the ln of 5. So we just have to find what the ln of 5 is and then divide by negative 0.3. What did you guys get for the ln of 5? 1.691. 1.609. And then divide by negative 0.3. Negative 5.364. Awesome. Good job. Any questions from this page? So now we're working with logs. So before we were solving exponential equations, now we're solving logarithmic equations. So if we have log base 2 of x is equal to log base 2 of 7, the log and the log cancel, and then we're just left with x is equal to 7. So super similar to what we were doing before. Let's look at example 3a. So what do we do first? What do you think?
Are we able to divide both sides by
Even easier than dividing both sides by ln, they just cancel. Since we have a single ln on both sides, they just cancel out. So then we're just left with 4x minus 7 is equal to x plus 5. So when you have ln of something is equal to ln of something, the ln's cancel, just set the insides equal to each other. Now we solve for x. What do we do first to solve for x?
Subtract, or minus x minus 5.
Subtract x, so 3x minus 7 is equal to 5. What should we do next? 3x is equal to 12. Divide by 3. What do we get for x? 4. Awesome. All right, let's do b. So here we only have one log on one side. We still want to get that log to cancel out. So we're going to do the inverse of log, which is an exponent. So we're going to take whatever this base is and make it our big base. So we're going to take 2 and raise it to the power of log base 2 of 5x minus 17. And whatever we do on the left side, we have to do on the right side. So this is 2 cubed on the right side. So what happens to 2 to the power of log base 2? Cancels. So then we're just left with 5x minus 17 is equal to 2 cubed. What's 2 cubed? 8. So 5x minus 17 is equal to 8. How do we solve for x? So 5x is equal to 25. What do we get for x? 5. That's our answer. Example 4. Again, we're solving our log equation, but it's a little bit different here because we have 2 logs on one side. Ideally, we just want 1 log. So how can we combine these 2 together? Condense it together. Awesome. Since we're adding, to condense it to 1 log, we multiply them. So this is log of 2x times x minus 5 is equal to 2. What should we do next to get that log to cancel? What's our base here? 10. If it's not written, remember it is 10. So what can we make the big base? 10. And then whatever we do on one side, we have to do to the other. So we have 10 to the power of log base 10 of 2x times x minus 5 is equal to 10 to the power of 2. So what happens to 10 to the power of log base 10? Cancels. So then we have 2x times x minus 5 is equal to, what's 10 squared? 100. Now we solve for x. So what should we do first to solve for x? Distribute. So 2x squared minus 10x is equal to 100. What can we do next? Subtract the 100. So 2x squared minus 10x minus 100 is equal to 0. What should we do next? We want to factor out a 2. So we could just factor this, but since we start with a number that is not 1, we want to divide whatever that number is by everything in our equation. So we're dividing everything by 2. So then we're left with x squared minus 5x minus 50 is equal to 0. Now we can factor. What are 2 factors of negative 50 that add to negative 5? Negative 10 and 5. Perfect. So we put those into our parentheses. X minus 10 times x plus 5 is equal to 0. How do we solve for x? Set each part equal to 0. X minus 10 is equal to 0. X plus 5 is equal to 0. So what do we get for x? X equals 10 and x is equal to negative 5. Awesome. This one was a bit tricky, but you guys killed it. Good job. So let's check for extraneous solutions here. Plug in 10 and negative 5 if we have log of 10 times 2, so log of 20, plus log of 10 minus 5, which would be 5. So these are both positive. 10 works. If we plug in negative 5, we would have log of negative 10 plus log of negative 10. Can we take the log of negative 10?
No.
Nope, because it's negative. So x is equal to negative 5 does not work. It's not always going to be the negative number that doesn't work, so you just have to plug it in to check. Can't take the log of a negative. All right, number 5. What can we do here? The ln's just cancel. So then we have 7x minus 4 is equal to 2x plus 11. Now we just solve for x. What should we do first? Subtract 2x. So we get 5x minus 4 is equal to 11. What can we do next? Add 4. 5x is equal to 15. What do we get for x? 3. And we're done. Any questions on this one? I'm going to skip 6 and just go to 7. We'll come back to 6. I just want to write 7 below it. So we have log of 5x plus log of x minus 1 is equal to 2. What should we do first here? Awesome. We want to combine our logs to just one log. And since we're adding, we multiply them together. So 5x times x minus 1 is equal to 2. Now how can we get rid of that log? The base is 10, so we make the big base 10. So 10 to the power of log of 10 cancels. So we have 5x times x minus 1 is equal to 10 squared. What's 10 squared? 100. Now this is just like example 4. What do we have to do to solve for x? Distribute the 5x. So we have 5x squared minus 5x is equal to 100. What should we do next? Subtract 100. 5x squared minus 5x minus 100 is equal to 0. What do we do next? Divide everything by 5. So we get x squared minus x minus 20 is equal to 0. What's next? Factor it. What are two factors of negative 20 that add to negative 1? Negative 5 and 4. So we have x minus 5 times x plus 4 is equal to 0. X minus 5 is equal to 0. X plus 4 is equal to 0. What do we get for x? X is equal to 5 and x is equal to negative 4. Good job. Any questions here? All right, let's go back to number 6. So how can we get that log base 2 to cancel out? What can we do for number 6? Make the big base 2. So 2 to the power of log base 2 cancels. So we're left with x minus 6 is equal to 2 to the 5th power. What's 2 to the 5th power? 32. Now we just solve for x. Add 6 to both sides. X is equal to 38. Any questions here? All right, last one, number 8. What should we do first? Combine. So we have log base 4. How do we combine?
X plus 12, and then edit parentheses x. And then you put 4 base on both sides, and then x parentheses x plus 12 equals 64. X squared plus 12x minus 64.
Oh my gosh, you're going so fast. X squared plus 12x is equal to 64.
Minus 54.
Subtract 64.
X plus 16, minus 4.
So you said 16 and negative 4. So we have x plus 16, x minus 4,
X equals negative 16.
x plus 16 is equal to 0, x minus 4 is equal to 0, x is equal to negative 16, and x is equal to positive 4. Good job. Alright, so I didn't have time to get to this in the last class, so I'm just going to do it with them tomorrow, but I'll do it with you guys today. One thing that we have to check for in our answers is, it's called extraneous solutions. So if we get an answer, we have to check and see if it works in our equation. So one thing that we can't have is we can't take the log of a negative number. We did this in the last couple sections. We said we can't graph the log of a negative, because if we put log of negative anything in our calculator, it says error. So we can't take the log of a negative. So we always have to take whatever answer we get and plug it back into our equation and see if we're taking the log of a negative. So here we would have log of negative 16 plus 12 plus log of base 4 of negative 16 is equal to 3. We just said we can't take the log of a negative, and this would give us a negative 2. We can't take the log of a negative, so negative 16 does not work. So that eliminates one of our answers there. We can plug 4 back in to check. It would be positive, so 4 works. So anytime you have two answers like this, you always want to plug them back in and make sure you're not taking the log of a negative number. So let's check for number 7 also. So plug 5 and negative 4 back in. We would have, let me change the color here. This would be log of 5 times negative 4, which would be log of negative 20. So what does that tell us about negative 4? Can't use it. Does not work. So our only answer here is x is equal to 5. So anytime you get two answers, you have to check for extraneous solutions.